In this lesson, we're going to be solving this problem. This problem is under the strength of material under solid shaft. Here, the problem statement, it reads as follows. A solid shaft with a diameter of 75 millimeters transmit 37.25 kilowatts at 120 revolution per minute. Determine the twisting moment in Newton's meter and determine the shear stress in shaft. But given the diameter here it's a diameter, it is 75 millimeters, which is 0.075 meter. Then we're given this, it is the power, this one. Power, it is 37.25 kilowatts, of which it is 37.25 times 10 to exponent 3 watts, like this. It is 37.25 times 10 to exponent 3 watts. Then we've got this, the rotational speed here. It is N is equal to 120 revolution per minute. We're not going to convert this one. We'll convert it straight to the formula. Then here they say you must calculate the twisting moment in Newton's meter. When they are talking about the Newton's meter like this unit, you must know that they are talking about the torque. It is the torque that is measured in this unit. And like this, it is the torque. So here in this question number 1, we are required to find the torque. Then to find the torque, you know that we have the formula for torque. It is a torque is equal to pi divided by a 16 times the shear stress times the diameter to the power 3. It's because here we're talking about the solid shaft. That's why we use this. Then here we don't have the shear stress here. The shear stress, we'll find it in a second question. So that means we have 2 unknown for this equation. That means let us look for another equation which can help us to find the torque. Then because here we've got the power, that means we must take the power formula. The power formula, it is power is equal to 2 pi times the rotational speed and the torque that we're looking for divided by 60. This 60 is for converting this rotational speed into revolution per second. So here we're looking for this torque. We'll make the torque a subject of the formula. Torque is equal to power times 60 divided by 2 times pi times the rotational speed. Here, let us move like this a little bit. Here, we have to substitute the power. Here it is 37.25 times 10 to exponent 3. That's the power. Then times 60. Or the conversion of rotational speed, it is 60. Then 2 times the pi times the rotational speed, of which is this one. It's 120. Then the answer we get there, it is 2964.26 then Newton's meter. That is a torque that the question 1 it's looking for. Then because we have found the torque now, let us find the shear stress. Now we go back to this formula, because this formula has got the shear stress here. Then we'll make the shear stress a subject of the formula on this formula. So let's say a shear stress, it is equal to a torque times 16 divided by the pi times the diameter to the power 3, like this. Then here the torque, we just found it now. It is 2964.26 times 16. This 16 all divided by pi times the diameter here. It is 0.075 to the power 3. Let's move a little bit up. It's gonna give you 47.42.8. Then divide. On the bottom, it's gonna give you 1.33 times 10 to exponent negative 3. Negative 3. Then when you divide these two numbers, they're gonna give you 35660,751.88 Pascal. Then this it's gonna give you 35.66 megapascal. That's the final answer that we are required to find from this problem statement. On question number 1, we're required to find the torque. We found it. Here it is. On question number 2, we're required to find the stress. Here the stress it is.